Welcome, welcome everybody. I fixed my mic, so hopefully it should be, let me make sure. Yes, it should be fine, so I don't have to hold it up to my mouth anymore. Welcome to tonight's pregame show for the League of Extraordinary Inventors. I'm the Benefactor, an independent researcher, and your host here on Beneficence TV, where I disseminate all forms of forbidden knowledge. Now, tonight I have some really exciting news. We are going to do a full breakdown because I have a full working prototype of the Lightning Thief Gen 1 that we're going to be sending out to the team. So at this point, it works perfect. All I have to do is make 5 more. And when I do that, I'm going to send these out to the team. But today I'd like to give you a little sneak peek at the features, how to run the device, and a sneak peek at the instruction manual and some of what's in it that I will be including with the device for the team. Now, I only had, this is functioning as a beta test for the consumer version, so I only had limited resources. I did limit it to the first wave of our team members to 6. But if you are not included in that first wave and you would like a device to test with, please reach out to me. I just have limited resources, so I wanted to prioritize the team members who actually had coils ready and could use this and kind of beta test it and work out all the kinks. Because eventually I will be looking for a manufacturer to make a more professional version of the device. Right now it's kind of makeshift and crude. It's just a crude prototype. This isn't the actual one that we'll be showing off tonight, but just an idea. It has the banana plugs. They work perfect, so you can get the resistance for your potentiometer quite easily, and I'll show you how to do that, the process to tune your coil, how to hook it up, everything. And it also has the swappable board, so I'll go over that as well. Everything tonight is going to be really exciting, along with the lumen lamp. So and as you guys know, we are opening a shop for you guys. Some of these products should be available late 2025, early 2026. I am taking reservations for the Lightning Thief. I will provide the link in a few minutes on the chat. But for the other devices, we aren't taking reservations at this time because I want to make sure we get all the kinks worked out of everything first. But we're rolling out our first device as the Lightning Thief device. Then we aim to roll out the Green Machine, which is a pulse width modulator. And it's an all-in-one device. If I can get the coil that we're going to be going over again. Another interesting update with the microvortex. I don't know if you guys were paying attention last time. I gave you the update on the microvortex. It's done. I just need to kind of hook it up to the lumen lamp board and see if it works. I haven't been able to tune it with the Lightning Thief, but we're going to hook it up to the lumen lamp and see if that works too. So if that works, that's going to be our coil that we are going to be using for the all-in-one Green Machine device. So that's going to be like a pulse motor device, so you can drive a rotary, a magnetic rotary, or a motor of some kind. It's going to be really cool, because if you've been paying attention with these coils, when you drive a rotary of some kind, specifically a magnet, so we put a neodymium magnet sphere inside the vortex of the coil, and when it spins up, it actually reduces the input wattage requirement. So we looked on the Wattman, and it reduced like 32 watts, I believe. We got it to reduce on the input requirement, which is extremely phenomenal. Regardless if it's over unity or not, no other device is going to be able to do that for you. So and we're going to try like I'm doing all this on a shoestring budget, so it's going to be a slow process. I'm open sourcing everything. Michelle and I have everything in the public domain. We're providing later this week. We're going to provide the 3D files. He already sent them to me. I just need to sort them and put them on the Patreon and all that. They're not going to be behind a paywall. But if you do the free subscription, you know, go to my Patreon and there'll be a free subscribe, and you'll see it at the end of the week. Probably on Sunday I'll put it up there, and I'll try to put it up on YouTube. I don't know if there's an option to do that on YouTube, but definitely Patreon is going to be the place, and I'll try to link to it in future videos as well. But we do have the 3D files. Everything is in the public domain. We're going to go over further tutorials on how to wind the fusion coil for the lumen lamp and all that. But you have all the information to build the lightning thief if you want it. If you want it now and you are a tinkerer and you want to like build the jewel thief and just see what it's capable of, it's all in the public domain. So we're just trying to provide this technology to people who need it the most, and that's why I'm trying to keep this on you know, like at cost or near at cost. I know I have to, you know, make a few dollars per device to keep the business sustained, but we're going to try to keep it as affordable as possible. I don't know exactly how much this device is going to be, but I'm aiming to make it less than $40. So right now I think I can get it to be around like $25-30, but we'll see because I still have to go through the beta testing. So we're going to break down the full functionality of the Lightning Thief device, and as you can see, this is Michelle's board. It has the open method and the on this side it has the open method and the closed method. We'll be able to toggle between the two quite easily, as you'll see in the demonstration at the end of this presentation. So at the end of the presentation I'm going to explain everything, then at the end of the presentation I'm going to switch to a quick intermission so that I can get the camera ready and give you guys an actual demonstration of the device, how to tune it, how to tune your coil, how to hook it up, and all that good stuff, all the features, and the full breakdown. So that's going to be pretty cool. Again, I do want to emphasize, this isn't actually going to be what's inside. I'll show you a picture in a minute, but all of these parts are going to be screw terminals. So you're going to be able to swap out the transistor, you're going to be able to swap out the diode or the resistor, and the potentiometer is going to slip out quite easily. So you can modify it, upgrade it. You know, if something burns out, you can swap it out. You won't have to like buy a whole new device if you know how to do that, and it's quite easy. We're going to make it as streamlined as possible for the consumer version. Again, I don't know quite what that's going to look like, but the device works, and I'm really satisfied. And the lumen lamp works brilliantly, and I'm really satisfied with that as well. So let's start the presentation of the Lightning Thief Gen 1 prototype. So as I've said, it's fully functional. The only part we are missing is the 330 picofarad capacitor, which works with Michelle's coil. I haven't actually used it. So I tried using the Ian's cap bank just briefly. I didn't really mess with it too extensively. I'm sure that there is some kind of capacitance that I can use other than the 330 picofarad with one of my coils. But when they get here, you know, that'll be easily just fit in there with the screw terminal. It's nothing soldered. Nothing's going to have to be required soldered. So you can swap that out. And also, I do have an inlet for Ian's cap bank, because I was so inspired by the capacitor bank and its functionality. It's kind of going to be able to work in parallel with the Lightning Thief here very well. You just attach, you open up the device, attach two, open up the lightning thief device, and then attach two jumper cables to the capacitor area, the capacitor bank right here, which is in parallel with the open circuit load. So yeah, just put two Arduino jumper cables, and then there'll be like an inlet right here. You just wire them through there, and that'll be your output and input for the capacitor, and you can hook up Ian's cap bank like that. So that's going to be really cool. Again, I've already used the cap bank. It works. I just haven't found the right capacitance. And I don't have the 330 picofarad to see, because that's what Michel found for his coil. Mine is relatively the same size, but it might not be that that capacitance we're looking for. So we're still going to play around with that. So what's inside the box, though? Well, we have one lightning thief device. I'm going to include at least one or two neon indicator lamps extra, so that the team has a couple of options, and if one burns out, they have one. So at least one or two extra neon indicator lamps are going to be included per set. I'm going to also include not just the MJE13009 transistor that I've been using, but the MJ21194 transistor as well for you guys to try out. That is the one that Michel has been using. That's the one that's recommended by Bedini in some of his circuits, and the MJE13009 is what Gerald recommended to me. So we'll get into that in a little bit, but I will also include a couple of different potentiometer caps for customization, because I have some extra ones that'll be easily modifiable for you guys. You know how to put those caps on. And one 330 picofarad capacitor per device, obviously. And I'm going to also include a couple of extra 1K ohm resistors, the 2-watt rated. One is installed already, and then two for backup purposes in case you burn it out. I don't know what you guys are going to be doing. I mean, some of the team works with really high voltage, so that'll be interesting to see. And that's what's actually going to be included with your guys' packages. For now, I might include a thing or two more, and we'll go over some easy devices that you can get that will allow you to adapt the device for different power sources and all that stuff. So going into the instruction manual. All right, so I am excited to present the Lightning Thief Gen 1 prototype to the team. It's been developed in collaboration with Michel Morel. This is utilizing a modified ABHA excitation circuit from Daniel Nunez's One Stop Energies. And Michel modified this to work with our coils, because we don't have the Nunez coil. We had to use our own coils. So this is basically a modified Joule Thief. That's it. And it is designed for experimental purposes and research, but also for off-the-grid, easy applications and lighting. And we're going to also test with heating, too. It should be good with heating in some capacity. I just have to figure out how to do it. We're going to go into that in future streams, though. But whether you're an experienced researcher or an independent innovator, the Lightning Thief provides an excellent platform for exploring high-efficiency energy systems, systems that recycle the energy instead of waste it. So while this is just a prototype aimed at researchers and tinkerers, we are working toward a consumer version that will bring these advanced technologies into the homes, workshops, and beyond, offering significant benefits for energy savings and emergency power use. So the team's feedback will be critical in shaping the next version, the consumer version of the product. This is, again, this is considered the beta testing. I'm going to send 6 units out to the team, and then I'll continue to make more for the rest of the team as they beta test these units. So a quick overview of the features. The Lightning Thief Gen 1 prototype is a precision tool designed to help researchers and innovators explore the fine-tuning of bifilar coils. There are 2 main operating modes available, the closed circuit method and the open circuit method. You can easily toggle between the two using a built-in toggle switch. So, it's a next-gen circuit to squeeze every last drop of energy from your power source. So the recommended power source is the 12-volt battery that I've been working with. It's a 20 amp hour. But it does have the ability to pull extra energy from batteries. Other devices think that other devices think are dead. You know, when the device won't recognize them anymore, this one just keeps going and going and draining and draining. So you got to watch it. It has unmatched efficiency, as we've seen with some of the calculations that I've been trying to, do to gauge the efficiency of the Lightning Thief system. Michel's modified ABHA excitation circuit ensures optimal energy extraction and recycling. So it's very, very good at recycling the energy and not wasting a lot of it. So it's ideal for off-the-grid lighting and hopefully heating during critical moments. This is why we want to get these out into as many hands as possible. I know I use it, and I could have used it, years ago. So, eco-conscious power works wonders with 12-volt sources or lower for sustainable energy use. But the ideal power source is the 12-volt. So the Lightning Thief turns waste into watts. So it's essential for off-the-grid living. Some of the key features are a closed circuit and open circuit method, as we've discussed earlier. 4 bifilar coil inputs. So we have 2 channels for the bifilar coil that you're going to be using. It doesn't necessarily have to be a Rodin coil or an ABHA coil. Technically, any bifilar coil will work as long as it's within the size range as the same that we've been testing. If it's really, really small, it might require, as we've seen with the microvortex, might require some tuning. But as the device is easily modifiable, you should be able to modify the device to customize your needs for research and development purposes. So it's going to have 4 inputs. I'll show you in the demonstration. You just put 4 wires input here. So it will also have, in the consumer version, multi-purpose power input. So a DC socket is going to be the ideal version for the consumer. But for now, we just have the two positive and negative wires coming out of the device. So it's a little crude, but it works. Again, this isn't supposed to look pretty. It's supposed to work first, and then we'll focus on making it look more pretty. The potentiometer for precision tuning. So the potentiometer, as I'll show you, is right here. Actually, you know what? I have another one right here. What am I doing? So my mom sent me this, and I'm still not convinced that it actually works. It's called Power Factor Saver. She claims that it saved her 20% on her energy. And all it does is smooth out the signal. And I was skeptical because it does this after the grid, or after the meter already calculates the energy you're using. So I was immediately skeptical of this working. But it perfectly fits the Lightning Thief. So look at that. We actually have a device that is going to save you power in here. So irony. But this is the device. As you can see, it has the neat little neon indicator lamp right here. When you're in tune, it'll light up without a load connected. With the load connected, it should light up the light bulb or whatever. This is the potentiometer you're going to be using to tune it. Very cool. It's smooth. Oh yeah, it's smooth, baby. That's a nice potentiometer. It's a 1 mega ohm carbon lined potentiometer. So it's going to be pretty hefty. It's not invulnerable though, so be careful. Careful. Don't want to burn it out. I know Nathan likes to say fry it and find out, but please don't fry these prototypes. At least not intentionally. Be delicate with them. They are not made out of good plastic. When you unscrew them, I've found that it's best to not use electric drills or electric screwdrivers. Do it by hand. Essentially, the plastic is kind of flimsy. I will provide the team the 3D files in case the case cracks or something, so you can easily whip up another one. And I will be including an extra board. That's something that I forgot to include in what's in the box. There will be an extra PCB board for you guys to, make another device if you want to utilize the dual thief setup, which we will be going over in the the demonstration after this presentation. Hey, what's going on, Turbo Spice? Thank you. Thank you for the membership. All right, we got the whole team here. Yes. All right, and Mike sent me the email, so we're all lined up for the League of Extraordinary Inventors. Let me get through this presentation. We only have about an hour, and we have to do a quick intermission where I have to set up everything for the demo. So let's punch through this. All right, so setup and operation. Let's go over setup and operation real quick. I'm trying to cut this a little short because we're going in a little longer than I expected. Yeah, we'll do 2 more chapters: setup and operation and optimizing the device for efficiency. So setup and operation of the Lightning Thief device. Power supply and wiring, the power inputs. So the Lightning Thief can be powered via 2 wire inputs. These will be replaced with the standard DC power socket in the consumer version for ease of use. Bifilar coil connections. As we've discussed, there will be 4 inputs, a start and end for channel A and a start and end for channel B, where you connect the bifilar coil. The consumer version will utilize 2 standard 1/8-inch auxiliary cable sockets, so just headphone cables. So there will just, instead of that complication, it'll just be 2 headphone cables, 1 for each channel. Wham bam. So that'll be very simple to do, and it'll be very convenient because when we sell the coil, I haven't yet come up with a housing to make the socket for the coil, but we will do the a headphone jack for the coil as well when I sell the coils on our lab shop. So the closed circuit versus open circuit method. The toggle switch can easily toggle between the two. But we will have 2 different outputs. So if you want to use one method or the other, you have to use one of the load outputs for the open or the closed. So there will be output load negative positive for the open circuit method, and then there will be an output negative positive here for the closed circuit method. And the open circuit method is the one that includes the 330 picofarad mica capacitor in parallel with the load. This is swappable, and I suggest using 2 Arduino jumper cables placed right in the capacitor pin terminals for connecting anything that won't easily fit inside the case. So like I've mentioned before, this is the method, and this is what inspired me to do the inlet for the bottom of the case. where you can feed those jumper cables through that inlet and hook it up to Ian's cap board here. I actually have it right here. Let me show you Ian's cap board. Because this is such a nice device that Ian sent me. It's even got my name. He even put Ben on there. That's so cool. But yeah, look at this. So this will allow us to more easily tune the capacitance, because if you've been following my research, you know that the load itself acts as a capacitor. So you want to tune the capacitance to match the resonance of the coil and the rest of the system. So the capacitance can, depending on what load you have attached, can really set off the resonant frequency and change it. And you don't want that. You don't want it to change too much. You want it to stay ringing. So this capacitor bank will allow us to easily be hooked up with the Lightning Thief. So it's going to work quite well together, Ian's cap bank and the Lightning Thief device. So much thanks to Ian for sending this beautiful device. Look at how nice this device is. So yeah, that was very, very nice of Ian to send that. And it's going to be very helpful, because again, I haven't been able to tune this capacitor or find the capacitance necessary to tune my coil specifically. We're still trying to determine what the proper capacitance is for at least the Lightning Thief device. Now with the green machine, with the Nunez open circuit method, with the stereo amp receiver being the driver, that method, we know, we already know that information. So the capacitor that Daniel recommends is a 0.1, I believe, microfarad Tesla 2000 volt. Yeah, I believe that's the capacitor that we're using for that method, and it works. So, but for the Lightning Thief, we're going to need to match the system and be a little bit more specific with what we're requiring, depending on what we're attaching as in terms of light bulbs, because different light bulbs have different wattage requirements, and they essentially act as different types of capacitors. And they could, as you know, a capacitor alters the frequency of your system. So it alters the frequency, and it can change the resonance there. You don't want to fall out of that resonance range. So it's all relevant. And we're all working hard to try to make this device as streamlined as possible for the consumer, just so that it's just basically plug in and play. So tuning the device, adjusting the potentiometer is quite easy. So once you have it all hooked up, you use the potentiometer to fine-tune your bifilar coil, and you just simply twist the potentiometer slowly. You don't want to go too fast. But once you achieve resonance, you'll see the neon lights start to excite and light up. So the indicator lamp, here, I'll show you right here. The indicator lamp will light up when it's in tune if you don't have any kind of light bulb or load attached to the output. If there's a load attached, this sometimes will light up, sometimes won't, depending on what kind of wattage requirement. So this is a very easy way to tune your bifilar coil. Basically, that's it. And once you achieve the resonance, you stabilize the potentiometer. You just, meaning you just don't twist it anymore, and you turn off the device. And then there will be two banana sockets down here, and I'll show you that later in our demo, that once you turn off the device and disconnect the power from the battery, the source, that's very important. You want to disconnect it from the battery as well when you're reading the resistance of the potentiometer. So you plug in your banana plugs and your multimeter, and you can read the resistance for the potentiometer, and that will tell you what ohms of resistance you need to replace this potentiometer if you want it to be permanently in tune. So you don't want to mess with this at all. You want, you have like a light or something you want to power it with. You don't want this to be out of tune at all. You don't want standby mode or anything like that. You want it to be permanently in tune. You take that measurement and then you open the device up and you disconnect the potentiometer from the two screw terminals, and you simply put in the appropriate resistance and resistor. So for the Mark 1 coil, for instance, I think it's either 10 ohms or 20 ohms, something like that. Pretty cool. Pretty cool. So standby mode. If you want standby mode, keep the potentiometer in, and when the device is detuned, meaning you're not in tune anymore, like you found your spot, it's maybe, for us, it's basically, depending on the orientation of the cap, it's about 9 o'clock. So basically you only twist it a little bit and you get your resonance range. It's right at the beginning because it's, again, it's, 10 to 20 ohms, and it's a 1 mega ohm resistor. It can go all the way up to 1 mega ohm. So it's right at the beginning. But detuning it means you're outside that range. So just twist it outside that range, and when it's detuned, the light should turn off, depending on what kind of light you have. There are some loads, like the 0.6 watt LED light bulb, that will stay on when it's detuned, which is really interesting. But it will enter sort of standby mode for most light bulbs. And what this means is the current drain at the state is very minimum. And it could last days, even weeks in this mode, depending on what kind of battery source you have. For our battery, 12 volt, 20 amp hour, it could last a good week in standby mode before we notice a significant amount of drain where we have to recharge the battery. Now compare this to like the lithium battery of my Steam Deck device. You put that thing in standby mode, after about 24 hours, your battery starts to drain quite significantly, and you can't even turn it on after a couple days. Whereas this, right, I think it calculated it to be about 15 hours for a 0.01 volt drainage on the battery. 15 hours. To put that in perspective, what we've been getting is generally around 0.01 per hour. That's already very efficient. Okay, but in standby mode, it's basically nothing. So 15 hours per 0.01 volt drainage on the battery, that's basically nothing. It could last weeks, depending on your battery in standby mode, which is pretty cool. So you don't even have to worry about unplugging anything from the battery. You just detune it and put it in standby mode. That's what I've been doing. Very cool, very cool. And it works. I've been doing it for about 2 months now. All right, so standby power in standard low power devices. So as I was discussing before, let's compare. Small IoT devices or wearables get about 10 to 50 millivolts per hour. That's, already we're beating the hell out of that. Modern smartphones in deep sleep get 1 to 5 millivolts per hour. Ultra low power microcontrollers. This is our realm. We're about 0.6 or 0.7, I think, millivolts per hour. So that's our range. Ultra low power microcontrollers are the only thing in this range of, in terms of standby mode power efficiency. Very, very cool. So the Lightning Thief's about, it's a 0.67 millivolts per hour. Millivolts or microvolts? I think it's millivolts. Anyways, it drains exceptionally efficient for a low powered setup. It is 10 to 50 times more efficient than standard IoT devices or wearables. It's on par with ultra low power microcontrollers, which are specifically optimized for such performances. And there's a lot of time and resources that go into designing that kind of system, so it's specifically optimized for that efficiency. This is achieving that efficiency pretty easy. So the Lightning Thief standby power consumption, if the 0.67 millivolts per hour is accurate, is significantly better than most standard low power devices. This efficiency makes the lightning thief setup suitable for long-term battery power use. It could potentially last for weeks and still turn on a light. So, optimizing device startup for efficiency. Hey, we got somebody coming in with the stickers. Yeah, I think it's millivolts. I always confuse those two, to be honest. So optimizing device startup for efficiency. Proper startup procedure. To maximize the efficiency of the Lightning Thief Gen 1 prototype, it is crucial to follow a specific startup sequence, okay? Particularly regarding the load's negative connection. This is very important. So the initial connection, we need to ensure that the load's negative wire remains connected before powering on the device. This setup allows this kind of setup allows the circuit to achieve proper oscillation, referred to as the system singing, or I'll sometimes refer to it humming, or in tune. You'll hear it. It's a high pitch noise that's coming literally from the light bulb itself. It's very, very cool. But there, that's when it's achieving oscillation. We can later disconnect the negative wire on the load and get it to stop singing and increase the efficiency. So that's kind of like stabilizing it. So powering on. So after you get it to sing, you turn on the device and turn on your or connect your load, basically, and wait for the oscillation to stabilize. Okay, you can identify this state by observing the consistent operation of the coil and load with a multimeter attached to the positive and negative terminals of your battery. All right, and once it's singing, once it's stabilized, you disconnect the load's negative wire. And this allows the coil to saturate. You can sometimes, Nathan prefers or recommends that you hook up a switch. And we have hooked up a switch. And this is to bash the button and kind of saturate the coil with that back EMF, that vacuum energy. So once you disconnect the load's negative wire, the system begins to oscillate and saturate in the coil. In this state, the system will operate at a reduced power draw while maintaining output efficiency. Nathan emphasizes this is due to the coil being saturated with negative energy and pulsing at the correct frequency as a result. This will also bring down the duty cycle to about 50-50, meaning that you're going to get the best efficiency at that duty cycle. So some key observations. If the device is powered on with the load's negative wire disconnected initially, the battery will drain much faster sometimes, and the circuit will not be able to oscillate correctly. Following the recommended startup procedure ensures optimal performance and prevents unnecessary energy loss. So you basically don't want to disconnect that negative wire until everything's singing to you, and you hook up everything, turn it on, start singing, and then you can disconnect that wire. But you don't want to disconnect that wire before it starts humming. However, additional notes. During operation, the battery consumption is significantly higher when the load's negative wire remains connected, but drops to match the light bulb's requirement when the negative wire is disconnected after the oscillation begins and then it stops singing. So this signifies it's eliminating the waste amperage. So it's basically stabilizing the system when you disconnect that negative wire. Always monitor the system during startup and verify the oscillation has stabilized before making adjustments to connections. So you want to try to monitor it when you first turn it on with an oscilloscope. Make sure the waveform is registering correctly and everything you're seeing, it lines up. However, I only observed the increased efficiency gain with my Mark I coil and a 0.6 watt light bulb. So this is very important. When you disconnect that negative wire, it's only for a specific load. So it's not for everything. Most things will actually turn off the light when you disconnect that negative wire. But with the 0.6 watt light bulb and my Mark 1, which is 6-inch diameter coil, using 23 gauge, I believe, using that specific light bulb, I would notice the efficiency gain, and the light would still go. And again, this is the light bulb that wouldn't turn off when it was detuned. So I think this is indication that it's closer to its sweet spot regarding the capacitance that we're looking for, and just naturally there with the 0.6 watt consumption from the system. So I think that is important to note, because that disconnecting that wire is not going to be for everything. In fact, it's not going to be for most things. Most things you're going to want to connect that wire. And also avoid frequent connecting and disconnecting the wire loads. Okay, so this can disrupt the circuit and potentially cause damage to components. You want to make sure the load wires are all safe and sound and connected securely. And this is because I've done this by accident. I've knocked one of the wires loose and burnt out the neon protection lamp. And this is not just an indicator that you're in resonance, it's also there for protection for the transistor. So this offers protection because it's drawing some of that voltage. When the load's not connected, it's taking some of that voltage, that high voltage, because this device has the ability to take that 12 volts from your battery source and step it up to potentially 120, and I've seen it higher. Very incredible. And with the ABA coil, apparently it's maintaining the current, which is absolutely mind-blowing. So that's the kind of efficiency we're talking about here. But this is there for protection, and it will burn out if you leave it on. So this isn't meant to be left on. This is just an indicator and a protection lamp. If you leave it on, it will burn out, and you will have to swap it out. And that's why I will include an extra or two for the team when I send these prototypes out. All right, so that's all we're going to get into for the instruction manual. I also have some updates on the lumen lamp. We're going to do a demonstration of that as well when we move into the demo part of this live stream. So as you know, if you've been following my research, the lumen lamp is a swappable coil setup, and it's ready to shine. Literally, I got it working. And we also have, Michelle also sent us the components to build one live on stream, which we are going to do in the near future together. Again, all of this stuff is open source. The 3D files I'm going to put on my Patreon free for my, free for everybody who subscribes for free. Not behind a paywall, but if you're just scrolling through the public, you won't be able to see it. But if you subscribe as a free Patreon subscriber, you'll be able to see it and download all the 3D files. This is just kind of to incentivize people to keep up to date with my Patreon, because that's where you'll get most of my updates and the YouTube membership. So I try to update both of you guys first. And I will give out a lot of free public information as well. So I just want to give some of the breakthroughs I do early for the paid subscribers. That's about it. Just to help fund this research, because I am on a shoestring budget. So this lumen lamp is amazing. It's absolutely astounding. I love it. It's adorable, and we're going to build one live on stream. And if you have a 3D printer, you can print out the components and you can build one with us. So we're going to do that in the future, maybe in another couple weeks. Also the transistor face-off. So be aware of this. Michelle versus me. So it's kind of like Pokemon Red versus Blue. Remember Pokemon Red versus Blue? At the start of testing, Michelle and I each picked our respective transistor Pokemon, right? Michelle picked the MJL21194, the Bedini recommended transistor, And I picked the MJE13009, which is what Gerald recommended. Now we battle to see how they've grown and what makes them different. So I like that reference. That analogy is pretty fun. I'm going to thus reference the MJE13009 as the Charmander and the MJL21194 as the Squirtle. So that'll make it a little bit easier to say those transistor types. So when you hear Squirtle or Charmander, I'm going to be referencing those two transistors because we're going to be able to swap out the transistor easily. You can choose your own transistor and see what happens. So pretty cool. Remember, the lumen lamp and the lightning thief will both be easily modifiable, meaning you can swap out critical components like the transistor to upgrade and adapt for your own project requirements. Another thing we're going to try to do tonight, if we have time, is the microvortex coil completion. Okay, we're going to try to tune that baby, and specifically, it wasn't tuning with the lightning thief because I had a feeling the 1 mega ohm potentiometer and the resistance was a little bit too high. We are going to try to hook that up with the lumen lamp board, which is basically the same, the Joule Thief board, modified Joule Thief, but with a different potentiometer attached. So we're going to try the microvortex coil with that, hopefully at some point tonight during the League of Extraordinary Inventors. That's going to be cool. Oh, and I officially got my own piezoelectric transducer. So I'm in the piezo group, baby. We'll try to hook it up if we have time as well. See if it can harmonize with tonight's experiments at all. So fingers crossed. Hopefully we get some sparks flying. Metaphorically, not real sparks. But I do have a extinguisher nearby if we get some literal sparks flying, just in case. All right, so the last chapter that I'm going over in tonight's presentation is Michel's North Pole Magnet Coil. This is one of his own discoveries, okay? It's a recent discovery of Michel's. He sent one to me, and this is probably why Customs opened my box. They're like, well, what the hell is this thing, man? What the hell? Yeah, it's basically two magnets glued together, north to north pole, with a coil wrapped around, and it's a bifilar coil. And he said that it amplifies the voltage even further without any cost of current. So I thought that was extraordinary. I hooked it up briefly for a couple of minutes. I couldn't get anything out of it. But maybe if we have time, we'll do some more experimenting with this bad boy. But this is very exciting too. I'm really excited to work with this thing because this has the potential. And as you know, it is, if you paid attention to some of my explanations on how zero-point energy works, magnets are nature's over-unity devices. They tap into the 0 point quite easily because they spin the aether around them. They do this and they generate enormous amounts of energy at no cost and for hundreds of years. So imagine the amount of energy it takes to pulse a piece of metal and make it a magnet, right? Imagine how much energy it costs you to pulse a magnet and make that magnet. Compare that to the number of years that magnet could sustain itself against gravity, right? And that amount of energy compared to the amount of energy that went in, no, there's no way. There's extremely large amounts of energy coming out compared to the input of a magnet. All right, there's no other device or whatever that can sustain itself against gravity for years like that. So that is key to how some of these free energy devices work. They're just understanding magnetism differently, and you'll understand magnetism a lot better if you follow Ken Wheeler's Secrets of Magnetism or Fractal Woman's breakdown of his Secrets of Magnetism. So that's all I got for the presentation today. we are going to get ready. I'm going to transition to a quick intermission, maybe 15 minutes, maybe less, depending on how long it takes me to get set up. And we're going to dive right in and have some fun and maybe blow a few minds along the way. So who's ready to make some lightning strike? Let's do it.
We're shattering the silence, feel the power, revelations on the rise.
Welcome, everybody. I'm the Benefactor. As you can see, we're printing out another case for the prototypes here. Here is our first fully functional Lightning Thief Gen 1 prototype. Okay, we have everything on this baby functional, and we're going to break it down for you right here. And then, real quickly, I'm going to demonstrate the lumen lamp before we head over to our main show, the League of Extraordinary Inventors, right here on Beneficence TV. All right, so I'm gonna grab the camera and we're gonna zoom in. Let me place the microphone in a place where you can hear it. Let's put this right over here. Alright, to tune your bifilar coil, as you can see I have this one hooked up to Mark 1 coil, and we'll zoom in the input in a second, but I have it hooked up to the 12 volt 20 amp hour battery. And I also have a secondary coil, the Christmas coil, sitting below it. As you know, the two coils will wirelessly induce energy from one coil to the next. And this is my dual thief setup, the secondary Lightning Thief device, which is not hooked up to the battery, just hooked up to this coil sitting below the one that is hooked up to the battery. So that's interesting. We'll demonstrate that in a minute. But first, I want to show you how to tune your coil and how to use the Lightning Thief device for your bifilar purposes. So as you can see here, we have our two channel inputs. We have 4 wires. We have the start of channel A and the end of channel A, start of channel B and end of channel B. For my coil, respectively, the colors are red, black, yellow, and then green. So you'll see that I color-coded them so they're easier to follow. So once everything is hooked up, simply toggle the switch. See, I'm using the closed circuit method. This is the open circuit load output. This is the closed circuit that I'm using. So we're going to toggle the switch from the open circuit mode to the closed circuit mode. Okay, and then we're going to begin to, let me unhook the light bulb real quick because we won't see what we're looking for with that. All right. So again, we're not hooking any load up. We're just trying to find our coil's resonance. So we turn it on, and now we're adjusting the potentiometer. Oh, there we go. We found the range. Okay, so we found our resonance range. What do we do now? If we want to replace that potentiometer, we have an option with the banana plugs here. So I'll show you in a second. Let me grab the multimeter. The first thing you want to do, though, is turn it off. Don't touch the potentiometer. You want to stabilize the potentiometer, turn it off, and then go ahead and unhook the battery source. Okay, unhook the battery. And then you can plug in your banana sockets. Right. It's hard to do without a cameraman. So, all right, they're in. And look at that. And look at what we get on our multimeter. 7.4 ohms. So that's going to be the ohms you need to replace a potentiometer if you want it to permanently be in tune. So that is a pretty cool feature, very, very convenient feature, in my opinion, for this device. Okay? And it works. Works perfectly. I am so proud of this little device here. And now we're going to show you what it's capable of doing regarding lighting. All right, so we're going to turn it on, and I now have the light hooked up. So let's turn this baby on. And again, sometimes, depending on what load you have, the neon might still light up. And this is indicating that it's still getting so much voltage. Again, that's protecting the transistor. So you can hook up a stronger load to this, and this will probably turn off. I believe this is a 5 watt or 9 watt LED light bulb. And if you want to detune it, this is standby mode. So simply detune your device until the light turns off. And you'll notice that it starts to stabilize, goes back up, indicating that it's, in standby mode. It's consuming a lot less energy, obviously. Pretty cool. About 15 hours per 0.01 volts of drainage on the battery. All right, so that's basically the Lightning Thief in a nutshell. We are going to actually show you the Dual Thief setup, though, because I will be including a PCB for the team to build a second Lightning Thief, if they wish to, and hook it up in this manner. But again, this only works for the ABHA or Rodin coil setup. You need these these specific type of coils because they induce energy wirelessly. I don't know a lot of other coils that do that. So what this does, and here I'll zoom in. So we have that on. We're gonna tune it back. The light is on. Again, this one isn't hooked up to the battery. It's just sitting below the one that is. So this isn't hooked up to the battery at all. It's just hooked up to this coil. It's another lightning thief. And watch what happens, because this is just detuned. I had to do this so it wouldn't burn out. Look. What is that? Oh, that's high voltage being induced wirelessly from coil to coil. And it didn't affect the light at all. At all. And let's look at the battery, if it went down more. The battery didn't go down more. It's staying at 12.49. If this was consuming more energy, it would be going down, right? You would see the 12.49 probably shift to 12.48, like it's actually doing now with this detune. So I tune it back. Let's see what the voltage is. So theoretically, this high voltage should be making this go down a little bit, drain faster. Doesn't seem to do that. Alright, so that is the lightning thief setup. This is the dual thief setup. In a nutshell, ladies and gentlemen, everything that it's capable of doing thus far for our team's beta testing, to see what it's further capable of doing for the consumer when we roll this baby out later this year. So, eat your heart out, Tesla and Elon Musk. We are going to move over to the lumen lamp, and I'm going to demonstrate that for you real quick before we transition over to the main show, guys. Introducing the lumen lamp. This is using Michel's own design fusion coil. Alright, we're going to show you how to wind this bad boy live on stream. He has a brief tutorial. He's going to make a more extensive one, he said, and we're going to do it together. We're going to wind this, put this whole device together live on stream. This is basically using the same circuit, only the closed circuit method of the lightning thief. And it's using a 9-volt battery. 9-volt battery. This battery is almost drained, by the way. It only registers at 7.8 volts. I do have new ones that we're going to test out tonight to see how long this will last. We can't put it up too much because I don't want to burn out the potentiometer. But look at that. We can put it up to about 1 o'clock on the dial, which is about 400 to 450 milliamps. Look at that. That's a 5-watt LED, by the way. Very nice. Very nice design by Michel. So if you're not subscribed to my channel or Michel's channel, please hit the subscribe button, hit the like button. It really helps out. And I will post Michel's bench, his channel on YouTube, in the chat momentarily for you guys. This is the lumen lamp, and it has swappable coils. You can use different kind of coils. We're going to actually try to hook up the micro coil to this board right here to see if we can tune that and get some kind of resonance out of that. So that's cool. We're going to do all that tonight. I'll be working in the background of the main show, as always, in the lab with you guys, providing breakthrough coverage of these free energy devices. This is the micro vortex coil right here. So we're going to plug this bad boy in to the board. Yep. All right. What is our time? We have a few minutes here before we have to transition over to the main show. I'll put the intermission screen on, and then the League of Extraordinary Inventors will be on at 9, hosted by Mike K. from Faraday. What I want to do with this lumen lamp is extend the board a little bit because it's a little compact, maybe make the board a little bit bigger, and then we have space for a custom bobblehead for each member of the team to sit down, kind of like that iconic Tesla photo where he's sitting in front of his giant pancake coil. We want to do that for the Fringe Science team. So imagine, you know, Nathan sitting down with a Nathan bobblehead sitting down right here, miniature. So I just shut off all the lights in the apartment. So what you're seeing now is all the light in this room is now being powered by radiant energy. So somebody asked, I think Elijah asked, will it be kits? So we will sell kits, but I am going to be selling pre-made coils as well. If you don't have the capability or the time or resources to make the coil yourself, I will be providing coils. So yes, I will be making coils entirely to sell at some point. I can't say when that will be. Again, we have to get the business started. It has to get off the ground, and I think the Lightning Thief will be vital to try to get it its footing regarding funding for further development and research of these devices. So that's going to be critical. If you do want to reserve your Lightning Thief, I will put it in the chat along with my Michel's bench channel momentarily when we transition over to the intermission in about 2 minutes. Again, All the light in this room is being powered by these coils, these two coils, with radiant energy. Thank you, Crypto. Thank you, Pictures in Motion. You guys are the best. I appreciate everything from chat, all the new members. You guys are the best chat anybody could ask for. I always emphasize the chat is the most vital member of our team for the Fringe Science team, the think tank that Nathan and I put together. And this is all because of that think tank. This device would not be here today. None of this would be here today without Nathan. So we have to give him a huge shout out for the guidance and also the 3D printer to make this happen. All right, this would not be possible without Old Man Bill's Nathan. He has been vital to the development of free energy devices in general, and the dissemination of the science behind it. And it's not that complicated. You don't need a PhD to understand this stuff. You just need a tenacious effort to learn, right? You just need the will to want to learn how these devices work, and it's pretty simple. Basically, right now, we're just utilizing the back EMF from these collapsing electromagnetic fields being generated in the coil. That's it. Alright guys, I'm going to head on over to address any questions in chat while we transition to the intermission screen and get ready for the main show, the League of Extraordinary Inventors, right here on Beneficence TV. Stay tuned.